I'm Sharon. I'm the co-founder and CEO of Lamini. Before this, I was computer science faculty at Stanford, leading a research group in generative AI, where I also did my PhD in generative AI with Dr. Andrew Ng, who you'll be hearing from later today. I also teach about 1 million people online in, you guessed it, generative AI. And before my PhD, I was a product manager at Google, and also a couple startups. Cool. And today I'm going to talk about, well, first, I'm just so blown away at the announcements this morning. Language models are truly magical. The generalization capabilities are incredible. I was just looking at the MMLU scores of Llama 3.2, 3 billion parameters, getting 63.4. I'm like, this is incredible. So I'm very, very impressed. And generalization has always been, very difficult thing historically in AI. But with generalization alone, these models, they make up facts still, right? They hallucinate. I think my co-founder ran ChatGPT on a Wikipedia page on the Golden Gate Bridge and asked it different facts that could be answered on that Wikipedia page. And of course it's seen it, right? It's a Wikipedia page of the Golden Gate Bridge. And it could not get even more than half of them right. So it does make up things. It doesn't have expertise, deep expertise in Golden Gate Bridge, but probably not your enterprise stuff or your use case either. And so they lack memory, they lack expertise. And so that's where this talk is going to center on of how do we enable that. And that is only possible because the Llama models are open, right? The architecture and weights are open, and that makes it possible to develop algorithms that are much more complex to make them have memory and expertise. So I started this company with my co-founder, Greg, who I think is worth mentioning a bit. So Greg Dimos, he is one of the original inventors of CUDA at NVIDIA in 2008. And he put the first language models and neural nets onto GPUs in production as opposed to CPU. And that was at Baidu working with Andrew, who introduced us. So yeah, that's us. So first, I'm going to take you through a little bit of a history, a walk through time a bit. I guess it's historical now, 2023. But that year, it was after ChatGPT, right? It was a couple years after that. So folks were largely playing with prompt engineering and retrieval augmented generation, or RAG. And then I think, from playing with that, people then threw those use cases into production. But a lot of people came up to me and said, Sharon, is this really it? Is this like general productivity gain really, really it? Are we just moving humans to humans in the loop over here? Is that really it? And then very excitingly, this year especially, but of course last year as well, open source models are close to taking the lead. This is a very similar diagram to what Lynn just shared, but essentially they're closing the gap, and a huge part of that is what Meta has done. And just to share with you, I don't know if you were there for it necessarily, but I remember the Pythia models. They were the top models at the time. And when you ask it, what is your name? It would say, my name is. So that was very familiar to me. And yet that was excellent. That was like, oh, yes, it could say my name is. So that was some of the top models at the time. But now Meta has been able to release these models, 3.2 now, right? Where we get a frontier model, essentially for free, in the sense that I think Meta has essentially saved us as a startup and our customers, who are Fortune 500 companies and startups, $1 billion in development. So this is very exciting here. But you see those points on a graph. Those are points. They are frozen. They're frozen weights, each of them, right? But our brains are plastic. And so these artificial brains, they should probably be plastic, constantly learning as well. And so a huge piece of that is, well, how do we actually instill memory? How do we actually instill expertise, which we as humans, everyone certainly in this room has, to do the different tasks we each need to do? So fine-tuning has become a huge piece of this year, and we've developed memory tuning, which has significantly reduced hallucinations, and I'll go through what that looks like as well. And then my sense is what's going on in the next couple years is this will then lead to deeper industry-specific use cases. Fewer people will come up to me and say, is this really it? And there will be pretty big use cases in production, given what I'm seeing today, that have very high ROI. This will also give rise to higher precision workflows. So if you can actually be much more accurate, if you can start talking about nines of accuracy, that becomes very interesting. And so you can actually rely on chaining these models together beyond just a weekend demo. And then finally, making these models a little bit more plastic, maybe not constantly learning, but regular tuning updates, which we're already seeing with some folks. And then finally, giving these models the ability to learn, the learning in machine learning, the intelligence in artificial intelligence, to continually update, just like us. And that'll give rise to these expert proprietary models that are much deeper and actually can be product lines. So we'll focus on this, essentially what's brimming on the future and what we're working on today. Don't just listen to me. Folks are just super eager to leverage Llama and go beyond what it can do and take it to the next step. This is a business intelligence agent. We see a lot of code agents, and this was really interesting with just RAG and regular fine tuning. And then, of course, customer service is also a huge area. Customer service agents, where to build a demo only takes a weekend. I think everyone in this room could probably build that by cloning some repo and extending something and hitting a few APIs, downloading the weights, of course. But to make it actually reliable system for hundreds of tools is not actually trivial to make that extremely reliable across in certainly this case where I think nearly everyone here probably has a big account there. So that's kind of what we're focused on, what I'm deeply interested in, and hope that this enables far more applications in the world. And it's what we built is something that wraps the Llama models. So at the very base layer, being able to accelerate the Llama models. I know Llama 3.2 is not there yet, but to accelerate the Llama models on top of GPUs, whether they be NVIDIA or AMD GPUs. And then above that, be able to develop expertise in memory layers on these models. And that's where we're really focused. And finally, offering a developer interface that is easy to use through REST APIs and Python clients. Cool. And so how do we actually do this part? This looks kind of magical. It's just a random slide, right? That is through a process called memory tuning. Which I'll go through a bit more technically a little bit more technically right now. So memory tuning is a technique that marries a couple different technologies together. One is mixture of experts, one is LoRa's, and the last one's actually information retrieval, not RAG, but information retrieval, the same parent concept. And it kind of pulls those different concepts together, and it's a mixture of at least a million LoRa experts. And they're tuned on Llama to create a mixture of memory experts, or pronounced mommy. Okay, so yes. So whoever laughed gets a mommy. All right. We're gonna go Oprah. Oh my God, he wasn't paying attention. Okay, so there we go. So mommy, what is mommy? Mommy acts as a team of a million different experts, each kind of specializing in a different area, and that's all learned. The tuning objective is bringing the loss to zero, which is computationally extremely expensive, but they're able to do this efficiently through this architecture, and that's to minimize hallucinations in each specialty. And these experts, they retrieve, they store, they learn these important facts, right, and committing them to great memory, and they directly impact Llama weights. They kind of understand how Llama processes things and adds additional information in there, and fuses that together, similar to how LoRa's do it. So at inference, what that looks like is mommy will dynamically select different experts based on the user's query, and that does not hit inference and doesn't hit latency, excuse me, just like in a regular MOE. And what the result looks like is extremely high factual accuracy. So being able to get from, like, let's say 3% or that, less than 50% on the Golden Gate Bridge to something like 98%, or to get even higher nines of accuracy. It's still the same low inference latency and cost, which is really attractive because you don't want to take a hit by adding so many more parameters. And it should be easy in a line of code. So this is just instantiating Llama 3.18 billion and then just running .tune on that data. For example, of Wikipedia article. So here are actual sample use cases. One is exactly the quote you saw earlier about the business intelligence agent. That team is a top tech company. I think probably nearly everyone here has their products, and they were able to get to 95% accuracy, which was their goal, in just a couple of days. And that was many iterations, right? That was like 30 iterations. It took a couple hours each time. And then Copy AI, which is an AI-first startup, they were able to get to 99.9% accuracy, which they needed for one of their Fortune 100 clients. And this was for function calling and classification. So it makes it possible for them to build out reliable agents. And finally, factual accuracy. Again, customer service, it might not be super essential for every single type of application, but where it is, getting the model to be highly accurate is important. Cool. So enough talk. Let's actually look at code, since I know a lot of people here are technical.
All right, we're going to generate SQL with Llama 3.18 billion. So first, you can import Lamini and a couple other packages here. You can instantiate the Llama 3.1 model by just passing in the string for it from Hugging Face here. So to Lamini.Lamini model name equals. And the schema we're going to look at is actually about the MBA. So you can see things about the team, the name, the jersey, about the salary. So you can ask a question, what is the 99th percentile salary in the MBA? And you can see that it provides example information like a $ here, that it's text, and where it has a nil value. Great. So in the system prompt, what can you do? You can tell the model that you're an MBA analyst with 15 years of experience. You can pass in that schema. And then I'd ask, just write me a SQLite query. Let's see how well Llama 3.1 does. We need to first format it using these prompt tags, which will make the final prompt to the model look like this with the user question here. And then let's store it in this variable here, pass it through the model. Here with Lamini, you can actually specify the output type, meaning this is structured output, just like in OpenAI. So you can actually just enforce this piece that is JSON, right? Enforce that it's SQLite query and that this will be a string. And so here's the output SQL query. Cool, it kind of looks SQL-y. So let's actually store it in here and run it through a SQL engine. So starting that up here and then writing a simple function to execute SQL. We execute SQL and the generated SQL, and unfortunately it errors out. Let's compare this to the correct answer. The correct answer is much more complex, right? It's able to filter out salary here, etc. So yeah, lots of things missing. Okay, so here's the reference SQL. We can also execute that and get the right answer. Okay, so this serves as a great foundation for a gold data set for evaluation to lift the accuracy of the model. And so that you can actually even baseline performance. So what does that baselining performance mean? It means taking more than probably one data point, but you can even start with as few as 20 and actually getting these question, answer, and SQL pairs essentially. And you really just need the question and SQL in this case. But here are a bunch of different examples. Cool. And you can use an LLM as judge to then ask if these reference outputs are actually similar or not, right? And specifically, we're going to run it through Llama 3.1. So it's able to take that prompt, ask if those data frames are similar. We use programmatic chain of thought. So explanation needs to be a string and similarity bool out to actually grab this similarity bool to then score the model quantitatively. Okay, so now evaluate it on that entire data set through that entire data set using that same evaluation pipeline above, and the model gets 10% correct. Well, never fear. This is where memory tuning comes in. So memory tuning is where you can now create data from this gold data set. So similar data, relevant data, to then tune the model to better accuracy. So here, again, you can tell the model that you're an NBA analyst, here's a schema, here's an example, question query pair from the gold evaluation set. And Give me a different related question though, and write another query. So give me another pair essentially. And then here's a little prompt engineering to enforce the output and give me an explanation. So here's again, programmatic chain of thought. There's a SQL query I want you to generate and a question, and Llama is able to produce those. Okay, so the generated query, we actually can run it through the SQL engine and see that it is able to execute. You can filter out any generated queries that cannot. Okay, you can also create your own if Llama is not able to, or edit Llama's answers if it's not able to. So here are a bunch of generated queries. This makes it so it's very, very fast and easy to scale possible queries used for tuning. Okay, now you can format all of that generated data into the prompt. And you also make sure, that's not overlapping with the goal data set in any way. And then you can load that data in where the input is just that prompt of, hey, consider the same things, very similar from above, but the output, the expected target is that actual generated SQL query. Load that data set up and then be able to just run llm.tune on that data set and be able to see the results. So you get a dataset ID, you can see your job status here in a UI. But let's take a look at what the original LLM did before we to compare results. And so you can just, again, pass that in here. Remember, the prompt looks like this. What is the 99th percentile salary in the MBA? And it's able to generate this SQL query. Unfortunately, it does not run. It does not execute invalid SQL. And it's malformed as well. And then we're able to grab the memory tuned model ID out. So that's what that ID ultimately looks like. And you can pass it in a very similar way and then generate a SQL query. Notice that you don't need the output type here anymore because it's already tuned to just produce SQL queries out when you ask something relevant about the schema. And then when you execute this SQL query, it's able to give you the correct result. We rerun this again on the entire goal data set for evaluation. And as you can see, that truly was a North Star evaluation so that it's able to now reach that 95% accuracy.
Cool, thank you. I think the one thing I was missing is just this high level concept that it's actually kind of incredible. You can use Llama to improve Llama. So it's self-improving. And there's actually no ceiling. We were talking to some of our customers as well as internal engineers, and they're like, there's not a single SQL query I can think of that I cannot figure out how to get Llama to generate, turning it into a mommy. So I think that's kind of exciting. I'm also holding a lot of these, so I'm just gonna throw out another one over there. Nice. That's right. Cool. So that was actually from a course that we jointly produced between Meta and Lamini and Andrew Ng, and you'll hear from Amit Sangani and Andrew later. Here is a special offer, MetaCon 24 for $100 of free credit on Lamini. If you want to get started, you can also, of course, read the docs and read the case study in greater detail, not just hear me talk in a couple slides and sentences. And then here's the course. This is us here. I think it was, honestly, I almost couldn't believe this user said this, but they said, Lamini's magic, the fine tuning was very fast. It lowers the barrier for fine tuning for us developers who are not ML experts. Also does help ML experts, I assure you. I achieved 95.83% of correct answers on my third iteration, while the RAG application only got 87.5%. And that was in their first hour. So that was pretty exciting. And I will throw out another one. Ooh, I'm so sorry. Maybe I'm not Oprah. Yeah. And anyways, that is it. Thank you so much. Oh, Debbie!